This is domains with exponential functions. So when you do these problems, the first thing you want to do is plug them in your graphing calculator or Desmos, like this. So you'll see immediately where your domain issue is. And you're not going to be using the math to verify it. What you're going to be using is the calculator to verify your work. So now when we get an answer, we can verify that our answer is correct using Desmos or graphing calculator. So if you remember with fractions, denominators cannot be zero. So the only difference now is that we're going to be having an exponential as part of that equation that we need to solve. And all we're going to do is use our normal rules that we used before. So we natural log both sides or rewrite it as a natural log. And we end up with natural log of 1 does not equal the natural log of e to the x, which would become 0 and x. So we now know that x cannot be 0. Going back to the graph, you can see that that's the case. Right there. We're getting a vertical asymptote at 0. So that means we were able to input every single value, except for 0, into our function, giving us an interval from negative infinity to 0, union from 0 to positive infinity. So that is our domain. Those are the possible inputs that we can plug into this function. So we can plug in any x value you want except for 0. Right when we hit 0, we get that issue. Well, let's look at another example that way it could look. So sometimes they won't write them as a fraction. So it's your job to notice that there is a negative exponent there. Like that. And so now we have a new denominator that can't be 0. And you may think to yourself, oh, this is good, because an exponential cannot equal 0 in this case, because it's impossible. No matter what exponent you plug in, you're not going to get 0. However, there is still this little fraction sitting at the top. So we have a 1 over x. And with that, we know that that cannot be 0. So we do have an issue. X cannot be 0. And you would know that there is still something else to look for because you're supposed to plug this in your calculator and look at the graph. So this is our graph of the e to the x over 1 minus e to the x. And you can see that we have an issue here. There's a jump right there. You see it? So right at 0, we do have an undefined value. So this is perfect. So right at 0, everything else is good. Everything else is good from negative infinity to positive infinity except for 0. So negative infinity to 0, union 0 to infinity. Now this doesn't mean that 0 is always going to be there. It's just because we're dealing with just plain old x on this situation. There was no shift, so we're getting 0. What about the next one though? So the next one we do have another denominator. So we say that can't be 0. And you don't have to worry about the exponent because the exponent doesn't have a fraction. So all we're dealing with is 1 minus e to the 1 minus x squared does not equal 0. And if we solve that, put a natural log on both sides, we end up with 0 cannot equal 1 minus x squared, which we can solve. That's x squared cannot be 1, square root, square root. X cannot be plus or minus 1. So our interval would be that everything on the line is good except for negative 1 and 1 from negative infinity to positive infinity. So negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. So again, everything here is good. We're good. Plug stuff in. Good. Plug stuff in. All the way off to infinity. Checking that with the calculator, we end up with this. And so you can see that same situation, that right at negative 1 we're having an issue, and right at positive 1 we're having an issue. So our graph is checking perfectly with what we're talking about. So we can plug in negative 10. You can plug in negative 9, negative 3, negative 2. Oh, you cannot plug in negative 1. It's not going to work. But then you can plug anything between like negative 0.5 or 0 or 0.5. But right at 1, up, issue again. But then everything past 1 is fine. 2, 3, 4, all the way to negative 10. It just keeps going down and down and down. So short story is you're just using natural log with an e to solve the equation. So you're just solving these domain equations that you create. using the same rules we've used before.